All right. So, the most important idea when studying motion is knowing where you are. The word position describes your location. Um, However, you have to specify your position relative to a known reference point. Okay, so always have to know your reference point, your frame of reference. Most of the time in physics, our frame of reference is going to be the Earth, because guess what? That's where we are, right? Okay. So we can kind of zoom in on that a little bit and say, for example, if you're 2 meters from the doorway inside your room, then your reference point is the doorway. This defines your position inside the room. You need a reference point and a direction to define your location. So before we can start talking about distance, displacement, speed, velocity, we have to know where we are. And so we have to know where is our point of reference, to know your location or your position. My position right now is in this chair, but I need something more than just right here. I need to know I'm in this chair that is approximately 3 meters from the door. No, not 3 meters, 2 meters from the door, okay? So your reference point is important. You need to have a reference point. So that next thing, frame of reference. Frame of reference is a similar idea. So frame of reference, hang on. Let's try and draw this with a straight line, because that's always better. Similar to the idea of a reference point, it is defined as the reference point combined with a set of directions. Okay, your frame of reference is your reference point combined with a set of directions. For example, and you probably want to write down the example. A boy is standing still inside a train as it pulls out of the station. You're standing on the platform watching the train move left to right. To you, it looks as if the boy is moving from left to right, because relative to where you're standing, he is moving. But to the boy, his frame of reference, the train, he's not moving. A frame of reference must have an origin and at least a positive direction. Okay? So your frame of reference is referring to where you are. So the boy in the train, if the boy is standing in the train, to him, he's not moving. But if you're on the platform outside the train, then he's moving. Kind of like us right now. Are any of us moving?
No.
To us, no. But if you're out in outer space looking at the Earth, what's it doing? Moving. It's spinning. The Earth is spinning on its axis. That's how we go from one day to the next day. The Earth spins on its axis. But we don't know we're spinning. We don't feel like we're spinning. Okay? So because of where our frame of reference is. All right? So frame of reference is your reference point combined with your set of directions. So I would write down the train example, just kind of give you a little perspective of what we're talking about. It doesn't have to be word for word. You can summarize that up. So you got this boy on the train and then a person standing on the platform outside the train. To the boy on the train, he's not moving. He doesn't know that he's moving left to right. The person on the platform, you can see that the train is moving. Okay? So that's frame of reference. There's a frame of reference for the boy in the train, and then there's another different frame of reference for the person standing outside. You ready? Okay, so position. Let's talk about the term position. Position is a measurement of a location with reference to an origin. So positions can be positive or negative. Make sure you understand that. Positions can be positive or negative because it all depends on where you are in relation to the origin. So think about a number line, okay? The symbol X is used to indicate position. X has units of length. The figure below shows the position of a school. Depending on what reference point we choose, we can say that the school is 300 meters from Juan's house or 500 meters from Joel's house. Okay, so here's our school. That's our position X. If we look, it's 300 meters from Juan's house or 500 meters from Joel's house, depending on your frame of reference, depending on whether you're at Joel's house or whether you're at Juan's house. Okay? So that's what we mean by frame of reference and by position. Position can be positive or negative. Good? All right, so here's another example. All right, so the shop. So we got school on one side, we got shop on the other. The shop is 300 meters from Juan's house, but it's in the opposite direction of the school. When we choose a reference point, we have a positive direction and a negative direction. If we choose the direction towards the school as positive, then the direction towards the shop would be negative. So it would be like saying Juan's house is the frame of reference, so that's our origin. That's the 0 point on a number line. Okay? And so we could say if we go in that direction, that's a positive. If we go in that direction, that's a negative. And that's being chosen. That's our choosing our origin, choosing our frame of reference. Okay? If we were to choose the direction towards the school as positive, then the opposite direction would be negative. Okay, so might want to write this down. Negative direction is always opposite the direction chosen as positive. Okay, so on a number line, we have a positive end and we have a negative end, and those ends don't usually change. Positive's always to the right, negative's always to the left. Well, in here, our frame of reference, we get to choose which side we're going to make positive, and then the opposite side is going to be negative. Okay? So here it is set up as a number line. So we have Juan's house as the 0 point, and we're saying if we go to the left, then that's a positive direction, and if we go to the right, that the opposite direction would be negative. And that's just because we chose that as our frame of reference. If I changed my reference point, I would change everything else, correct? Right. So your frame of reference and knowing that to start with is pretty important. Like I said, almost all the problems we do in here, our frame of reference is we're here on the earth. Okay, so that's our frame of reference. We good? All right. Displacement. This is a term we need to write down. The displacement of an object is defined as its change in position, final minus initial. It has a magnitude. Displacement has a magnitude and a direction. Therefore, it is a vector. Okay? The physical quantity is the magnitude. That comes from subtracting. And the direction means, did you go to the right? Did you go to the left? Did you go north? Did you go south? Whatever. Okay? So here is your formula for determining displacement. It's real simple. final minus initial, or change in distance, or change in position, change in position. So there's another way of writing it. That little delta sign, that little triangle you see, that means change in, and we're going to see that a lot throughout the year. And when you see that little delta, it's always final minus initial. Whatever it's in front of, it's final minus initial. Okay? So displacement is the change in position. Final minus initial. Okay? All right, everybody got that written down? Because that's like super important. If you didn't write anything else down, write that down. Displacement is a change in position. Final minus initial. That gives us the magnitude. It also has a direction that goes with it. So it is a vector quantity. So, and we'll talk about how we get the direction a little bit later. Okay, so now while we're talking about all this, I want you to be thinking about Juan and Tim and their discussion and see if we can figure out who's right, who's wrong, and who maybe just didn't use the right vocabulary. Distance. All right, so displacement does not depend on the path traveled. Notice it was final minus initial, meaning I do not care how you got there. I just care where'd you start, where'd you end up. I don't care about what happened in between. That's displacement. Distance, on the other hand, the word distance is to describe how far an object traveled along a path. So distance is the actual distance that was covered. And we use that with a little d. So x is displacement, little d is distance. And it's scalar, meaning there's no direction to it. It's a scalar quantity. Okay? Displacement is the shortest distance from the starting point to the end point. So in our little example, from the school to the shop, displacement has a direction, therefore it is a vector, but distance does not. So distance is the actual distance covered as you traveled. Scalar means that it's just a number, no direction. Doesn't matter what direction you took, it is the path that you traveled and the actual distance covered on that path. Okay? So any questions about the differences and similarities between the two? Make sure, because we're going to be working problems with these, make sure you read the problems carefully to know if you're trying to find displacement or distance. They are not the same thing. When you are using formulas, make sure you know that x is displacement, but d is distance. Because if you don't keep those straight, you're going to be using wrong formulas, putting in wrong numbers, and you're going to get frustrated because you're going to get the problem wrong. Do what? Yeah. X is displacement. Lowercase d is distance. So when you're reading a problem, make sure you know which one you're looking for. And if the problem says displacement, that's x. But if it says distance, that's something different. That's D. Do not try to interchange them. Okay? All right, so if we look at our little diagram again, our little number line with houses or whatever. Jack walks to school. So here's Jack. Jack walks to school, but first to his friend Joel's house to fetch him. That's an old-fashioned word, fetch him. Anyway, to fetch him. Then Jack covers 400 meters to Joel's house, another 500 meters to school, a total distance of 900 meters. So here's Jack. He walks all the way to Juan's house, picks him up, turns around, walks all the way back to school. So his distance is the total distance that he covered in doing that. Okay? But his displacement, on the other hand, is just the distance from his house, which is the frame of reference, to school. Okay? His displacement is only the 100 meters going to school, not the 900 meters he traveled to go to his friend's house and then all the way back. Yes.
Wait, so the father was going to school, so if he walked negative and if he walked back, he's back to zero?
Mm-hmm.
Okay.
So see, so he goes to so when he goes to Juan's house and comes back, he basically has zero displacement, correct? Because it's final minus initial. So it zeroes out. So his only displacement is the distance he went from his house to school. That's his displacement. This is because displacement only looks at the starting position, which is his house, and the ending position, which is the school. It does not depend on the path traveled. That's important to remember. Your displacement does not depend on the path you travel. It only depends on where did I start and where did I end up. Okay? And like we said with physics, one of the problem-solving strategies in physics is to sketch out a problem. So it might be good for y'all to do this little sketch here and to see why we can say that his displacement was only 100, because when he went to Juan's house and back to his house, that cancels out. That's no displacement. Okay? So probably be a good idea to draw out that little diagram at the top. While y'all are drawing, I printed off the requirements for Science Olympiad. If y'all are interested, let's see. Team may have up to 15 members. Maximum of 7th, 12th graders is permitted. So everybody, it's from 9 through 12. We have a maximum of 15 members. Recommends that the best team, so we can take those 15 people and divide them up into other teams for other things. So it doesn't really have a minimum number of participants that I can see. I know there are a total of 23 different events that you can compete in, so it's not just like a quiz round type thing. There are experiments that you can do, things you can build, STEM challenges, different stuff like that. So you get to kind of pick what event you want to look into doing. So I'll have that printed off next. I thought it told a minimum, but it's just a maximum. All right, everybody got this down? Okay. All right, so here are your big distance differences. So this would be a good thing to write down or do a Venn diagram or something. Well, not a Venn diagram, maybe chart would be better. So distance, three things. It depends on the path. Here's another important thing. Distance is always positive. And it's scalar. Displacement, on the other hand, is independent of the path. It can be positive or negative, and it is a vector as magnitude and displacement. So that kind of sums up distance and displacement. So Juan and Tim were actually talking about two different things. One mentioned the distance they traveled, whereas Tim was talking about his progress. So Tim was meaning displacement is what it should have said, whereas Juan was talking about distance. So they were kind of both right, but they used the wrong words, okay? So vocabulary, words, very important. So make sure you have those three things for each. That's a really good summary of the difference between distance and displacement. All right, you got those? Okay. Here's velocity. So velocity, write this definition down. Velocity is the rate of change of position. Tells us how much an object's position changes in time. This is the same as displacement divided by time. Since displacement is a vector, then velocity is a vector. So velocity is a vector. And we use the symbol V for velocity. Here is the formula. V is change in x over change in time. We got that little delta sign. Makes it a whole lot easier to write instead of having to write out final minus initial. But that's what it means. It means your final displacement minus your initial displacement divided by your final time minus your initial time, which is usually 0. Initial time is. So, okay. So another way to write that out as far as when you're putting in numbers and having to figure it out, it would be V final minus V initial, T final minus T initial. Okay, that's velocity. Velocity with a V. Yeah, I'm gonna leave it there for now before I say something wrong. You got that formula? So it's important to note that velocity can be positive or negative. Since displacement can be positive or negative, velocity can be positive or negative. And this is important for you to remember. So if it's a positive velocity, it's moving away from the reference point. If it's a negative velocity, means that it's moving towards the reference point. Okay? So if Carson runs away from me, if I'm the reference point and Carson runs away from me, then he has a positive velocity because he's going further and further away. His displacement is getting further and further. If he runs towards me, that displacement is getting smaller and smaller and smaller. So his velocity is a negative number because he's coming towards me. So the sign, positive or negative, tells me the direction in which he's moving. Okay, so you kind of have to get out of your head about signs, like you have in math. In math, we think of negative signs as being something that's like less than zero, and we think, well, that's kind of weird. That doesn't make sense sometimes. But when you're referring to displacement, the positive and negative just tells you your direction, whether you're running towards that frame of reference or whether you're running away from it. Okay. So average velocity, just like the name sounds, is the displacement for the whole motion divided by the time for the whole motion. Okay. So if I'm running a 1 mile race, I'm going to figure my average displacement by looking at the 1 mile as my displacement, or my total displacement, divided by the total time it took to accomplish that displacement. So if I'm running 1 mile straight out, then my displacement would be the 1 mile, and my time would be the time it takes me to get that 1 mile. So my average velocity would be displacement divided by time. Okay? But that's assuming, am I going to run the same speed all the time? No. Even without trying, sometimes we pick up our speed or we slow down. So we have what's called an instantaneous velocity. Your instantaneous velocity is velocity at any specific instant in time. So at 20 seconds in, what was my velocity at 20 seconds? That's your instantaneous velocity. Your average velocity is over the whole time that I was moving. Okay? Maybe you're, let's see, how fast can y'all do a mile?
18 miles. I'm a big guy, 9 minutes.
I'd like to be able to do it in 9 minutes. Okay. I'm a little more like 12 if something's, 10 if something's chasing me. Maybe 9 if something's chasing me. Anyway, so low fives. So probably by the time you get to that 5-minute mark, you're pretty tired, I would expect. So you might start to slow down. So your instantaneous velocity at close to the 5-minute mark is not going to be the same as the velocity that you started with if you're doing a sprint. Now, if you're doing a long run, you're probably going to start a little slower, and then you'll pick up your pace at the end. Try and save you some energy there. So that's the difference between average velocity, that would be over the whole time, and the whole displacement. Your instantaneous velocity is at one particular second of time, or even less than that. All right, so that's velocity. Now here's speed. Okay, speed. Symbol with an S. So far they make sense, right? Some of the older physics books made speed and velocity the difference between the letter V and the Greek letter V, which was really confusing because they're almost exactly the same. They're V and V. Evidently, newer books have changed that. And so speed is symbol S. And it's the distance, D, not X. D, the distance traveled, divided by the time taken. So since both of those are scalar quantities, speed is also scalar. So velocity is vector, V and V. That's easy to remember. Speed, scalar, S and S. Speed does not have a direction. Okay? It's just your distance divided by your time. So here is your formula. Okay, so far we've had about 3 formulas today. You might want to star those in your notes, might want to keep a running tab of them because you're going to need to memorize. So these especially are your easy ones, so you're going to have to memorize these.
Okay, question.
Yes, ma'am.
So when it says speed and the M with the S to the negative first power, is that the like SI units or something?
Yes,
Like,
that's the units. It basically means
okay.
meters per second. Whenever
Okay.
you see that little negative
Yeah.
1, that means per.
Yes, ma'am.
Okay. Good question, though. So speed is measured in meters per second, so is velocity. Okay, so they're the same unit, but you look for, does it have a direction to go with it? And you look at what the problem's asking for. If it's asking for velocity, that's totally different than finding speed. So don't interchange them. And you have an average speed, which would be what you have the formula that's there. Your instantaneous speed, again, would be the magnitude of the instantaneous velocity. So it is at any particular second in time, what is your velocity at that particular second? It has the same value, but again, no direction because speed does not have a direction. We're almost finished. So the next slide is going to look at giving us a list of the differences. So you might want to make you a little T-chart to give you a list of those differences. Sometimes they're easier to visualize in chart form than in just word note form. So has everybody got this down?
What's that way circle?
Let me erase my circle. Just means meters. It's just meters per second. They just went ahead and put in the unit. Those units are very important. You've got to always include your units. Your units are going to let you know whether you got a problem right or wrong. If your units don't come out to be logical, then you did the problem wrong. You used the wrong formula, you didn't convert right, something went wrong. So always put in your units because they're going to let you know if you got it right or not. Or if it's a logical answer or not. Okay. So here are our differences between speed and velocity. Remember, that was our objective for today. We wanted to know the difference between displacement and distance and between speed and velocity. Here they are. Speed depends on the path. It's always positive. It's scalar and doesn't depend on direction because, again, it's scalar. It doesn't have a direction. Whereas velocity is independent of the path. It can be positive or negative. It's a vector, and so it can have a positive or negative sign depending on which way you're going.
What does vector mean again?
Vector is change in displacement over change in time. All right, so now we can move on here. So what is the difference between velocity and speed?
What was that last one on the velocity?
It can be positive or negative.
Well, that was the one on like 2 above it though.
No, I don't think.
Yeah, that one.
Direction can be guessed from the sign, so it can be positive or negative. The direction can be positive or negative. That positive or negative sign you get tells you the direction. Okay, so tell me, in the Nearpod slide, tell me the difference between velocity and speed. And try to kind of summarize it and put it in your own words rather than just copy. I know you have it down in your notes, but it's good for your brain as far as helping to remember it. You can try and summarize it in your own words. If you're just reading and typing, you're not going to remember. So speed is scalar. It has no direction. Velocity is a vector, so it has magnitude and direction. That's the real difference, that it is the root of their differences. Okay, good. Let's see if we have another one. Velocity has direction while speed does not. So velocity must depend on, ooh. Did they get that last sentence right after the so? Is that true? So velocity must depend on the path taken while speed does not? Is that true? Got it backwards. That's backwards. Okay. All right, so we'll pick up here again tomorrow. You do have homework that I would go ahead and start working on, but check your due dates. We're going to spend 2 days in this section, so it may not be due tonight at 11:59. It is going to be the first 25 practice problems and lesson checks that are in 2.1 and 2.2, because that's what we covered. Okay? Alrighty, y'all have a good day.